This paper presents a motion planning framework for a legged robot that uses its limbs for non-prehensile manipulation, as well as locomoting motions. First, issues related to the description of the system and the task are presented, including the generalized dynamic model for a legged robot, and the dynamic model for an object being manipulated. Then we set the velocity constraint to prevent separation at the contact locations. For a sticking contact, there should be no relative velocity between the contacting substances. For a sliding contact, for example, if a box is supposed to slide on a flat floor, its contact with the floor will restrict its vertical and orientating velocities to zero. We also need to set the force constraint that restricts the interactive forces. For a sticking contact, the interactive force must lie within the friction cone, while for a sliding contact, the interactive force should lie on the friction cone's edge. These four elements are combined to generate the dynamic model for the whole system and produce the constraint for system motion. Then we reduce the system dimension by focusing on the control of one system variable, and get the admissible system acceleration as functions of the system state. The acceleration bounds can be visualized as cones in the phase plane. We propose a method to automatically create a feasible trajectory in the phase plane that moves the system from the initial state to the goal state. Finally, the robot motion can be generated based on the trajectory and system inverse kinematics. We tested this framework by controlling a quadruped robot to manipulate objects and locomote itself with drive mode, inchworm mode, scoop mode, and throw mode. In drive mode, the robot places its front feet on the mat and places its hind feet on the floor. The front legs hold the mat static with respect to the robot body, while the hind legs drive the robot relative to the floor. In inchworm mode, all of the 4 feet of the robot are placed on the mat. The robot adducts its hind legs to create a bulge in the mat, and then abduces its front legs to flatten the mat, making the mat move forward in a manner similar to the gait of inchworms. In scoop mode, with all of the feet on the mat, the robot first accelerates rapidly and then decelerates slowly. During acceleration, the mat slips relative to the floor while maintains contact with the robot. In throw mode, a cubic object is placed on the top of the robot. The robot pitches its body to reorient the object by throwing and catching it.